Hello, this is the simulation of the GOAT team. For the first scenario, in business as usual, we can see our facility. We have the total dollars, pounds, and euros in hand, the total revenue, the total cost, and the total swap performed. We have a source and a sink. The source is modeled as a money pistol, and the sink is modeled as a building. For the source, we have an inter-arrival time model as a beta with these parameters. And for deciding what type of transaction we are performing, we use a table named transaction, and the row number is referenced as a column named mix. That table is shown here. We have our 6 model entities that each model entity model a type of transaction. We have our column of mix and our column of amount. For all the model entities, we have an amount model of a wave, except from the euro to pounds, where we have a gamma. In our definitions, we have our output statistics, that is our revenue, cost, profit, total dollars, minimum euro, pound, and dollar, our impaids, and our cost opportunity. In properties, we have our 9 controls variables, and in our states, we have the same 9 variables as properties, and also we have our exchange rate, our minimums, and our impaids, swap flag, and total swaps. Our first process is the assignation one that occurs in the source. Here we assign the values of our properties to our states, so the states can change over the run of our simulation. And then we have our main process. The first thing to check in our process is which type of transaction we are performing. Here we have our pound to euros transaction. After that, we check if we can perform the transaction, and if we cannot perform the transaction, we increment our counter of impaids. If we can perform the transaction, then we subtract the transaction from the total euros in hand amount, and then add it to the pounds. After that, we charge our fee and we add it to the revenue. And then we check if the total euros has acquired a new minimum. If it does, then we change our minimum euro value to the total euros in hand at this moment. And then we check if we need to perform a swap. That is checked with this condition. And if we have to do, then we check if we have another swap in performing. It's important to mention that we only consider to have one swap occurring at the moment. So if any other currency needs to perform a swap and this swap is going around, then the swap flag is going to be up, and we could not perform another swap. If we need to perform a swap and there is no other swap performing, we trigger up our swap flag. We perform the delay model as a normal distribution of 30 minutes and a deviation of 2 minutes. Then we decide to which of the other 2 currencies we have to compensate. From this case, we are asking for a swap in euros. Then we have to check if the total swap or the total dollars or the total pounds are which is greater, and after that, we charge the total with the swap amount, and we add the total of our model with the swap amount asked. Then we charge our cost and add a total swap to the counter and trigger down the swap flag. At the end of the day, we perform this process. Then we check if our euros in hand are below our initial value of euros, also for pounds and dollars. And if it does, we charge our cost with the difference between the initial value and the final value of the currency, multiplied by the exchange rate and multiplied by the charge rate. After that, our opportunity cost is calculated as the sum of the minimums, all converted to dollars, and multiplied by the exchange rate, by the fee of 8% annually, and finally we sum all our costs here. Here is the model of the second scenario for our project. The main difference is in our data table. We have the same 6 type of transaction, but the mix values have been modified because of the year default, and also our amounts have changed. We can see all here are modeled as Weibull, and the values of the mix can be explained by the default on the currency of euros, and also the appreciation of other currencies like the pound or the dollars. As we can see, we have all the same definitions in elements, properties, states, and our process is basically the same. This is the model of the third scenario of our model simulation. In this scenario, we lose our ability to perform swaps. For that reason, we only have three properties that are the total dollars, euros, and pounds in hand. And also we have the trigger point and the amount of swap. As we mentioned, we lose our ability to perform swaps, and this is our logic. The only difference from our first model is that in the process add-on, in the output source, we end with the assign of the minimum value of each type of currency. It's the same logic. We found which type of model entity or transaction it is. Then we decide if we can do the transaction. Then we increment the total of one of the currencies and decrement the other one. Then we charge our fee, and then we check for the minimum. The assignation is the same, only that we have only 6 for the initial value of the dollars, pounds, and euros in hand, and the minimum also initialized as that. And then we check our settlement with CLS Bank at the end of the day. For the final scenario, we have changed the name of our variables from swap to settle here, also in our states. And for acquire the settlement policy, we have the same logic as the swap before, but without the delay, and also changing the fee to 0.001 here, and assigning that to our costs. And finally, we have removed the settlement policy at the end of the day, so we can initiate the next day with the last amount of our currencies. Also, our runs are of 315 hours, and we calculate our cost opportunity and we add it to our total cost. And that's it. Thank you for watching.